Assalamu alaikum. My dear students, our lesson today is about integration. We will start in LO 2.5. Our nice LO this year is about integration. We start from what we studied before, is differentiation. If we have y equal x over 2 plus 3, so its first derivative y dash equal to x. We have y equal x over 2 minus 5. Its first derivative also equal to x, because the derivative of any constant equals 0. Derivative of 3 equals 0. Derivative of -5 equals 0. If you want to inverse this operation, the question will be: if you have y dash equal to x, what is the initial function y? What is the function y? Which if we differentiate it, we will get to x. Someone can say y equal x power 2 plus 9. Another one can say y equal x power 2 minus 7. Another one can say x power 2 plus 3 or x power 2 minus 5. So we have many functions have the same first derivative, which is equal to x. All of them have the first term x power 2, and another term is a constant number. This constant number may be 9, -7, -5, 3, maybe 0. Y equal x power 2 x first derivative is x. Okay. So we have a family of functions. Their first derivative is 2x. This family of functions we call it antiderivative. Antiderivative. All of these functions are called antiderivatives of y dash equal to x. The process of finding the antiderivative, we call it integration. Okay. The reasonable notation for this operation is like that. This is the sign of integration. This is the original function y. Okay. Equal integration of the function f of x. If you remember, f of x was 2x. F of x equal to x. This is the first derivative, which we call it y dash. Now we are going to find y itself. Y itself is the integration of f of x dx. Dx means relative to x or with respect to x. This function is f of x plus a constant. F of x here, capital f of x, which was x power 2. So applying this notation to the previous example, y equal integration of 2x with respect to x equal x power 2, which is f of x, plus the constant c. X power 2 plus 9 minus 5 plus 1, x power 2 plus 0, power 2 itself, no problem. This is the sign of integration. Okay. This function, we call it the integrand function. The integrand function. This notation means we integrate with respect to x. this function f of x is called the integral of this function. So we have a family of integrals that all of them contain the function f of x and a constant. So one is the antiderivative or the integral of f of x with respect to x. Another example, find the function f that is the antiderivative of f equal f of x equal 3x bar 2. F of x equal 3x bar 2. We want to find a function f of x whose first derivative capital F dash of x equal this function x bar 2, 3x bar 2. What is the function which will, if we differentiate, we will get 3x bar 2. Okay, we can guess this function as x bar 3 plus constant. If we differentiate x bar 3, you will get x bar 2. The first derivative of the constant equals 0. Okay. So we can write that the notation of integration like that. Integration of 3x bar 2 with respect to x equal x bar 3 plus a constant. Okay. Now I'm going to provide you a general rule for the method for the bar function. How we can integrate the bar function. The rule is integration of x bar n with respect to x equal x power n plus 1 divided by n plus 1 plus a constant with a very important condition, which is x n not equal negative 1. If n equal negative 1, the function f of x will be in the form 1 for x. Now we don't have an integration with this rule. It has another rule. So if n not equal negative 1, we can use this rule. Integration of x bar n with respect to x equal x power n plus 1. You should add 1 to the power and divide by the new power. Okay. For example, if we have x bar 5, the integration of x bar 5 with respect to x is x power 5 plus 1 will be 6, divided by the new power, which is 6, and adding a constant c. Okay. We have x power negative 3 with respect to x. The integration of x power negative 3 with respect to x equal x power what? Adding 1 to negative 3, it will be negative 2. So it will be x power negative 2. Dividing by the new power, which is negative 2, and adding constant c. Okay, this is the first rule we use to find the integration of a function. Another example, we have 1 over x power 3. This function not in the form x power n. So we can put it in the form x power n by writing it x power negative 3 dx. It will be like the previous one, x power negative 2 over negative 2 plus constant. Okay. Now we have a very important notice. Before you begin exercise, be sure you realize that one of the most important steps in integration is the most important thing. Rewriting the integrand, the function which we integrate, okay, in a form that fits basic integration rules. The function must be fit the integration rule. We provide u, which was x bar n. Okay. For example, root x dx. Root x not in the form of x bar n. You can put it in the form x bar n at first, like that. X power half dx. Now we can integrate. By adding 1 to x power half, it will be x power 3 halves or 3 over 2, dividing by the new power, which is 3 over 2 plus the constant. We can simplify. Now we divide by 3 over 2. We can multiply by 2 over 3. 2 over 3, x power 3 over 2 plus the constant. And you can make this expression in the root form as follows: 2 over 3, okay, the square root of x over 3. This is the simplest form of the integration. The top 5 rules for integration. The first rule, x power n, integration of x power n. Okay. Now, if we have 1 over x, in this case, n is equal to 1. The integration of 1 over x with respect to x equal ln x plus a constant. Ln is the denominator function, which is x. Okay. Number 3, if we have a constant, our function is a constant function. So the integration of the constant function with respect to x will be the constant itself divided by x plus the constant c. We can prove it easily. Okay, if we differentiate ax plus c, its first derivative will be a. Only. Okay. Integration of e power a x ex, okay, will be e power the ax itself, okay, divided by the coefficient of x, which is a plus the constant c. If we have first degree polynomial in the form of a plus bx, okay, raised to the power n, and we wanted to integrate it with respect to x. Okay, x integral will be a plus bx itself, okay, power n plus 1, or n plus 1. Just add 1 to the power, divide by the new power, which was n plus 1, okay, and also divide by the coefficient of x. Coefficient of x, which is b. This is the derivative of what between the brackets. Dividing by the derivative of what between the brackets, which is the coefficient of x, the number b, or the constant b. Okay, so integration of a plus bx all power n will be a plus bx power n plus 1 divided by n plus 1 times b plus the constant. Okay, basic rules for for integration. If we have a constant multiplied by a function, so we can get the constant outside the integration and integrate the function as we did in the differentiation. The integration of the sum or the difference of two functions will be the sum or the difference of the two integrals. Okay, we can distribute the integration sign over the addition and the subtraction. Now we have a general rule for 1 and 2. F of x multiplied by the constant a, g of x multiplied by a constant b, we can get a integration of f of x plus or minus b integration of g of x. This rule, number 3, is a generalization of 1 and 2 together. Okay. Let's practice some problems using the previous rules. The original function is 2 over root x dx. The first step is rewrite the function, okay, to fit the rule. Okay. Root x means x power half, so it will be 2x power negative half dx. Now we have a constant multiplied by a function. So the constant is outside the integration, and integrating x power negative half will be x power half. By adding 1 to negative half, it will be half. Dividing by the new power, which is half, okay, and adding the constant. Now we have to divide it by half, it means 4. And x power half means square root of x plus 3. Now we get the simplified of the integration. If we have t power 2 plus 1, all power 2. This expression between brackets, not in the first power. T here power 2, t power 2. So it is not first degree. Okay, so we can't apply the rule before. Now we should expand the brackets. So t power 2 equal t power 4, 1 power 2 equal 1. Okay, 2 t power 2 times 1 equal 2 t power 2. dt means we make integration with respect to the variable t. Okay, now we can integrate t power 4 to be t power 5 over 5 plus we have a constant 2, write it as it is, and integrate t power 2 to be t power 3 over 3. The integration of 1 is x itself, because the first derivative of x is 1. So the integration of 1 will be x, and writing the constant c at last. Okay. Now we have x power 3 plus 3 divided by x power 2. We don't have a rule to integrate the quotient of two functions. Okay, so we must simplify this. Dividing x power 3 by x power 2, we will get x. Dividing 3 power x power 2, we will get 3x power negative 2. Now we can integrate. The integral of x will be x power 2 divided by 2. The constant 3 as it is. The integral of x power negative 2 will be x power negative 1 divided by negative 1 plus the constant 3. Okay. Simplifying, x power 2 divided by 2, we can write it in the form half x power 2. 3 divided by negative 1 will be negative 3. X power negative 1, we can, in the numerator, we can put it in the denominator as x power 1. Okay, plus the constant c. This is the simplest form. Now we have the integration of cube root of x multiplied by x minus 4 dx. As I said before, we don't have a rule to integrate the product of two functions or the quotient of two functions. So we must make this product. Cube root of x means x power 3 multiplied by x minus x power 3 multiplied by 4. X power 3 multiplied by x means x power 4 over 3 minus 4 x power 3 dx. Okay. X power 4 over 3. Okay. We can complete here. Will be x power 7 over 3 divided by u power 7 over 3 minus 4 as it is. X power 3 will be x power 4 over 3 divided by over 3 plus constant. To simplify, will be 3 over 7. The cube root of x power 7 minus 4 divided by 4 over 3 means 4 times 3 over 4. Okay, we will get 3. And this is the cube root of x power 4 plus c. This is the simplest form of this integration. Now I finished my examples. This page for you to solve. Find the integration of x power 8 dx, x power 2 third dx, the 7th root of x power 5 dx, 7x power 7 over 9 dx, two plus root x plus 1 over root x dx, integration of 1 over x power 2 plus square root of x plus 3 dx. Those examples for you. Solve them and send me your answers. I hope you understand the first session and integration. In the next sessions, we will go into rules of integration. We have many rules of integration in the next sessions, inshallah. Assalamu alaikum.